So can you all see my screen?
Yes, we can see that. Thank you.
Okay, so thank you first of all, Dana, for inviting me along today. I never imagined that I'd be presenting at a webinar in Latvia. It's a shame that we can't be together in person. My name is Carl Fitzpatrick and I'm originally from New Zealand. However, I've lived in Helsinki for the past 11 years and currently work remotely as the Building Information Manager for Auckland Airport back in my homeland. So it was a bit of a complicated situation and many late evening meetings with my colleagues back home. Prior to working for Auckland Airport, I worked as an architect here in Helsinki and as a model manager on large-scale healthcare projects at AW2 Architects. Saying that my current role as a BIM manager does not really capture the nature of my role, and instead the term Building Information Manager is what I normally use, as it implies that my responsibility is more to manage building information rather than managing just straight out models. And my role is quite varied and goes from a high-level strategy, producing the company standards, implementing technology, investigating new technologies, does involve some model coordination, a little bit of model authoring, and basically overseeing how a client organization adopts building information management and digitalization of its assets to sort of tie into a wider asset information strategy. So today, I thought, I could have spent 30 minutes spinning around models and impressing you with models, but there's already a few presentations online which I've shared links to here, which I suggest that you would go and look at these and get more of an insight into sort of the back-end technical aspect of what we do at Auckland Airport. But today I wanted to actually take the time to teach what I've learned over the past 20 years working with building information models, working as on the architecture side of the equation as well as now on the client side. And I hope that at some point during this presentation you'll get some new idea which can hopefully help the Latvian construction industry digitize in a better way. And I want to be clear that I'm expressing my own thoughts based on experiences over the past couple of decades from working on smaller residential projects all the way through to airports, and the views are not that of my employer. So it's more sharing what I've learned and just more of an overview of those lessons learned rather than a show and tell of what I've done. So I'm not a consultant and I'm not here to sell software, so this is just a presentation from someone who has worked on both sides of the supply chain. So the premise of the topic today and what I want to talk about is this idea of shifting from the BIM world in the asset creation phase, which is largely to do with design and construction, and shifting across this opportunity to the world of asset information management and creating value for our clients. So once the building is constructed, often the information just sits on a shelf within the client organization and nothing's actually done with it. And once a building is constructed, if nothing happens within the building, then it will typically lose value as it is not generating any income. And if it's not looked after, the asset will also lose value as the cost to fix it becomes too high. So from an asset information management perspective, it is about the building data, using the building data to improve building performance and increasing its value over time. And real estate is some of our most significant assets, yet in the context of asset management, the physical asset itself is not often given as much attention as it deserves. And most asset managers are dealing with strictly financial assets, and they often just see the building as a line on a spreadsheet. And the role of asset management in the context of the built environment, which is gaining more and more interest in the industry these days, is more about increasing the value of the actual built asset and enhancing the asset portfolio over time while mitigating risk to the owner. And the role of building information models in the field of asset management is growing. And from my experiences, I've seen it having a lot of potential to unlock significant value and create new market opportunities. So the question that I'm often trying to answer at Auckland Airport is, how can asset creators capture information in a way that enables better full lifecycle asset management of the asset beyond the design and construction phase? So today I want to shed some light on what I have learned and what I believe are some fundamental truths that the industry needs to recognise in order for us to truly benefit from the potential of digitising our built environment. So how do we move beyond design and construction into a world of asset and facility management? So first things first, I would like to point out the elephant in the room. All too often I'm in meetings where people are referring to BIM and saying that BIM can or can't do something. And I'm quite often amazed that when they say BIM can't do something, I think, well, actually there is a tool that can do that. And after a while I think, hang on, maybe they're not talking about BIM. And then I ask, when you say BIM, what do you mean? And often the answer will be Revit. So what I want to clear up today is that in order to move the conversation of digitising the built environment beyond where it currently is, we need to get out of this proprietary trap and talking about particular tools. And if you are referring to BIM as Revit or Revit as BIM, just in the future, please just refer to it as Revit. It is what it is. And I think it will save a lot of confusion going forward. I see a number of times where you're having the conversation, it's around an issue with software rather than with the data and actually coordination. So on that perspective, at Auckland Airport and in my own work, I strongly believe in open data and using open data standards to build a connected ecosystem of data and technology components that can evolve and change at an individual level and still keep a complete system working as a whole. Large assets or buildings are quite complex, and there's many different parts, and no one tool does it all. So we need to move beyond just trying to convince everyone to use one tool and into a world of open standards and letting people use the best tool for that particular job. It is also important for designers and engineers and contractors to understand that the client's role in the process is quite different to theirs. And the client does not typically have an office full of technical savvy architects and engineers, and they don't necessarily care about the same problems. Therefore, the tools that the client chooses should be based on their own needs and not necessary to fit the needs of their suppliers. And this is why the industry needs to adopt an open approach to BIM and not be defined by proprietary file formats. So as an example of that, at Auckland Airport, this is our current technology stack. And while at a project level you might get one software being used, when you consider the whole asset lifecycle, there are more challenges to solve than one software can solve. So therefore it is important to think of your BIM and asset management setup as a connected ecosystem that will change as your business matures or transitions to new ways of working. So this current technology stack for us, we use this to produce, share, audit, analyze, and visualize data. And we still have a lot more to do in terms of fully integrating with the business-wide system of the airport, but good things take time, and we're evolving in line with finance, the finance available, the nature of our projects, and the particular strategy of the business at a particular point in time. And as humans, we tend to want to simplify things and find one solution that does it all. And from experience, I can tell you that there isn't one to do it all. I see countless presentations from software companies who claim to do it all, but they can only do it all within the context of what they know. And as I said before, every organization is different. The people within them have different skill sets, have different attitudes to change. Businesses don't always have the money to invest in specific tools, or there are other more pressing issues that require investment. And in the world of BIM and digital twin, the talk of digital twins, there is often a tendency to think that we have all the answers to the universe and everyone else is just stupid for not realizing it. But I think we need to realize that we just are part of a wider business's asset management strategy. And so why talk about asset information management in a construction industry forum? And my question is that how many of you as architects, engineers or contractors have put in a lot of effort throughout the design and construction phase, utilizing BIM and ensuring everything is coordinated correctly, only to save the files on an archive server and then have nothing done with that for the rest of its life? Effectively, we're leaving a whole lot of value on the shelf. And I would say this is the case in 90% or more of projects. And this is not the fault of the architects, the engineers or the contractors, but it's rather that the client has not yet seen the value in having detailed information about the asset, that they have significantly invested in. And it is crazy to think that many building owners and operators have such poor records of their built assets and often rely on one or two people with institutional knowledge in their heads to answer the questions. And this can often you'll find cases where people have been working in a business for 30 years and it's just asking them a question to influence what can be $1 million worth of investment decision. And admittedly, this is a hangover from the days of pen and paper drawings. But now is the time to advance our information management into the 21st century and use the tools that we have and understanding that we now have at our disposal. Our future asset owners and facility managers are currently in high school now and doing most things from their mobile devices. And we need to think that when they enter the workforce, are they going to want to do things the old school way? I don't think so. So therefore, we need to start looking at how do we bring up the industry to the latest technology and processes so that we can inspire the future generations to want to look after our built assets. And the father of management thinking, Austrian Peter Drucker, made the statement, which I strongly believe applies to what using building information models and asset management is about. You can't manage what you don't measure. Like how many asset owners do you know that? How many asset owners know how much space they actually own by use category, or how many square meters of carpet they need to replace in the coming year, or how much is it costing them to clean their facility per square meter, or what building materials are costing them more to clean than others, and how many people can their building actually fit before it becomes uncomfortable to use, and how does social distancing impact building performance or usage. So from an asset management perspective, having more detailed built asset information can greatly help enhance the whole user experience of the building and the value by maximizing rental income, maximizing the passenger experience or people using the building's experience because it's not too crowded, ensuring that everything's working and everything's clean and tidy. And many buildings are poorly managed, and over time they'll reach the point where it's actually cheaper to pull them down than fix them up. So I think we need to take more responsibility about our assets and not have this disposable attitude to infrastructure and start to actually take better care of our assets. So in order to start moving towards a world of asset information models, we need to change the way that we think about models within the industry. It is easy to see BIM as a shiny three-dimensional model that can be used for nice marketing presentations and clash detection. This is perfectly fine in the design and construction phase, but from an asset management perspective, there's so much more information about the building that does not sit within the model, such as product information and O&M information, regulatory information, and things which can help enhance the building throughout its life cycle. And current BIM processes largely focus on the 3D model. So we need to start thinking it more as a collection of data of the 3D aspect, the non-graphical data such as the plan documents and the specifications, product information, O&M manuals, and we need to package this all together in a way that it can be easily found and used. In addition, well before design often starts, the information management process actually begins, yet we only start modeling projects in the design phase. So there's a whole period before the design phase where we're actually capturing information in a sort of disorganized way, and we're waiting until a model exists in order to have BIM information or building information. In fact, it already starts back when the client is deciding that they want to have a building in the first place. So when we think of the task of information management, it then helps to understand the project as a series of progressive steps starting right back at the business need. When a client decides that, hey, we need to build something to answer a business need. And then at each step, asking the question, how can we best manage information so that we aren't duplicating effort throughout the project? Too many times I see information being handed around as Excel sheets or independent Word documents, and nothing's really searchable or interlinked. And this simply means that we're often handing data to the next person to then manually input it back into the model to then spit it back out. So we really need to understand all the different phases of the project and at each phase what the model is going to be used for and what information we need out of that model to actually help the project as a whole. We often produce 2D plans as a communication tool to either show what we intend to do or give instructions to another party. And the only way you should get away with not producing information is if you're building something entirely for yourself that doesn't require any external input. And in most cases on projects we're working with other people, so we need to think about how can we each produce, store and share information in the best manner possible so that we can each focus on doing what we enjoy doing rather than simply double handling information. And one major lesson learned working on big hospital projects and airport projects is that the larger the built asset, the less it makes sense to manage the data through the model themselves. And so I tried to explain it here in this diagram that we often have, as I said, double handling information, and we're feeding it down to a BIM modeler who then inputs the information into a model and then shares that model with another party. And then you combine models and that they've got the same people on that team doing the same job, where they're just taking information from other people, pushing it to a model, and then exchanging models. And this is effectively a process that is too complicated and it is hard to manage, particularly in the asset information phase, because most client organizations don't have a team of 10 BIM modelers to tell the information to then put it into the model. And what we need is that the person who is the source of the information can directly contribute to the model. So we need to shift to this thinking of having the 3D graphical component of the model and then a separate database which actually hosts all the building information data right from the initial space requirement phase all the way through to the handover phase. And the model is simply linked to the information within that database. So if you have a door, the information sits in the database, the door is modeled with the authoring tool, and you're simply linking to that record. Likewise, attaching all the documents. So this is really this concept of what's often referred to as a common data environment, but most common data environments now are simply just sharing the model files, much the same way you do on a file server. But this here is more at an attribute level, sharing building data between a database and the other components. And the reason for this is that when we then get into an asset owner organization that has multiple systems, they're also managing data across multiple databases. So here's an example from the Auckland Airport, where every one of these items here is a separate information database that a particular part of the business is using to inform their daily job. So when we start talking around digital twins and having this view of everything in one model, what we're talking about is how do we connect all these different data sets that sit in different databases to the 3D component. And then what that allows us to do is then make sense of the data, and then once we've made sense of it, we can then make decisions based on it. So we're moving up this decision-making pyramid, and then that improves decisions, and we feed it back into the data management at the bottom, and then continue the process. So it's really splitting out, understanding that we have geometry which we can then associate data to. We then have static data, which is your typical plan documents, any report, manual PDF documents. And then we have all that dynamic data which is changing. So all these IoT devices, or someone changing who's leasing a particular space, or changing information about they've changed the lock on a door, that they've actually changed the lock, and all that maintenance information. So when these three come together, then we start to get to this idea of a digital twin, where we have all of our organizational data linked back to the building geometry which has been created during the design and construction phase. And often within organizations, what we see is that technology is driving the change, and people are going out and buying tools and then bringing a tool into a business and then trying to think that that will solve the problem. And we need to flip it around and actually first understand the problems, understand the people within our organization and how they want to operate, and then select the tools based on those needs that we discover. It's too often, there's plenty of technology out there. We get bombarded with it all the time. And you invest in one tool and then the next week there's a new tool out and then the next week there's another tool out. And I think what we need to do is just understand that it's all about the people rather than throwing shiny new tools at them. So it's like the Formula One car that, you can have the fastest car to get from A to B, but if you don't have all the people servicing it, making sure it's up to date, and you've actually got a well-trained driver, that you actually get to the place you want to go any faster, and most common people would probably crash. So it's the same with BIM technology. And another huge thing that I've seen within technology within a client organization particularly, which are typically much larger, is that the change within the organization is much, much slower than the pace at which technology is changing. So here's this law called Martech's law, which comes from marketing technology. Guy Scott Brinker came up with this curve, and I see it firsthand within the organization I work for that there's so many moving parts within an organization. There's so many reasons why things can't happen fast and processes to go through, yet technology is changing super fast, and you have a whole lot of consultants and even people within the organization, myself included, saying, oh, we should adopt this, we should adopt that. But you have to factor the actual, what is the organization ready for? There are only so many changes that people can make, that so many processes you can change at once, and without causing major disruption. So how do we close this gap? I think first we need to treat it like a journey and not a destination, as the destination is always changing. And a perfect example of this was last year at Auckland Airport, where we were in the process of investing $2 or $3 billion over the next 5 years on capital infrastructure. We had people on the ground digging foundations. We had design teams working across 20 plus projects. And overnight, because of COVID-19, that all came to a stop. So we went from this full-on program where our supply chain was modeling our future projects in BIM. We were working towards gradually building up the data over the course of projects, so it met our asset information requirements. Then all of a sudden, everything is cancelled and those plans go out the window overnight. So we had to change course and switch our focus onto the more challenging task of capturing our existing asset data rather than focusing on how do we improve the new asset data. So we need to treat it not like a race. And a big part of that journey is actually building capability within your organization. It is not enough to throw an iPad at a project manager and expect them to manage everything via models. And often on projects, the current process, we have project managers, design managers, lead architects, structural engineers. We have all the different disciplines involved. And then the BIM manager is a bolt-on at the end to make sure that they all produce BIM models. But what the industry needs to fully take advantage of the technology is we need to actually build that capability across all those roles. It's not enough to just go and hire capability to make up for the fact that someone doesn't want to learn something new. So then what you end up with is people still doing stuff the old way, and then someone beside them doing stuff the new way, and not really working in sync. So what we need to do across all organizations is actually get everyone, not necessarily, they're not authoring the models, but utilizing the models for design review, because then you can visually comment on designs, not just on static 2D plans. You can have project managers, checking the timelining of the project within the model, and having a much greater understanding of how it's going to go together, and just little bits throughout each role, improving their capability so that then everyone can benefit from the power of utilizing digital modeling. Now, this is much harder to do than simply hiring someone to do the job, because it requires everyone to get on board and take the effort to learn, and it also requires the investment from the organization. And another thing around BIM is there's a lot of talk around standards, and in most cases it is just talk as people continue to debate about what standard to follow, and should they adopt open standards, or such as those developed by Building Smart, or use a proprietary system and standardize around a particular modeling tool, such as Revit or Archicad. And I think we need to think of a good way of, I understand you Latvians are good at bobsleighing, so we need to think of the standards like a bobsleigh track, where the track is there, it gives you the way to go, and you can choose to just blindly accept them and not steer your way down and put your team at the mercy of the track, which in most cases will lead you to flipping up and crashing, or you can learn how to understand the curves, the standards, and use them to your advantage. But in order to make it successful, you need to have someone who's leading the way within the organization, such as the driver, and then you also need to have people who are there willing to pump the brakes, because often the driver gets so excited by the technology, but they're not tied to the reality of how the organization is moving forward. So it always pays to have a brake man, and then the rest of the organization are in the middle. They just need to keep their head down and hold on for the ride, and basically do as they're told. And because too often when you're trying to implement standards, someone will put their hand up and say that we need to develop a new standard. So I suggest you just pick a standard, learn how to use it, adopt it, and run with it. In terms of what I see has been fundamental to being able to utilize BIM models within the asset management space is actually modeling the space. Often it's the question of what came first, the chicken or the egg, but then the question is, was it actually the space that contained the egg? And I think with a building, well before we actually have a physical space design, we have a requirement for a space. And from that moment, we actually then can already start attaching information to that space. We can have a requirement that it needs to be a certain size, it needs to contain a certain use, it's going to be used at a certain time, it needs to be a certain temperature, it needs to fit certain objects, and all those things can inform design, and they can also allow us to actually understand the project and the cost implications well before we actually go to the phase of design and construction. Because too often we start designing things and then realize that the space is too big, and then we have to scale back, and it becomes a much harder task to scale back once you've designed the first thing that looks good, and then having to shrink it down. And this happens too often in architecture, and I think a large part of that is not fully understanding the requirements up front in the process, which is what in the software development world, they really want to understand what are the user requirements rather than just going out and building something. So, and what I mean by that, like I'll show some models now, like we have a terminal model here. And from just spaces alone, if you forget the model aspect itself, just from spaces alone, we can have a whole lot of information. We can see how much space we have here, airside or landside. We can then have a look at our reporting areas and seeing where we have to report to the airlines, where we're our lease charges, so we can see what's commercial space, what's common space, what are tenancies, where's retail, and we can start to actually get a much better understanding of our building, and then use all these different ways of viewing the data for taking off information, and then also tying, we can tie as much information as we want to these spaces, so we could utilize it for cleaning, calculating replacement costs for furnishings and fittings, using it for, here we've got fire evacuation zones, so we can start to see, what rooms are fire routes, what do we need to keep clear, the different fire evacuation zones. So this helps with doing our fire evacuation maps. We can see where everything is, looking at rooms by size, so we can find available rooms of a certain size for particular tenants, and also their type. So just with spaces alone, we can achieve quite a lot in a model without, fully having to model in detail our existing facility. And then, along with all this, we then need to make sure that all of our building information is structured and well maintained, so that it actually has value during operation. So it's the same as within a library. Imagine all the books in the library were just dumped on the floor and you had to find what you wanted. It wouldn't work. So it's the same with a building. There's so many parts within buildings. For example, our airport, we have over 300,000 elements modeled just in one terminal, and if we actually had everything modeled, we'd have more than 1 million. So there's 3,000 doors alone. So there's a lot of information, and we need to treat it like a librarian would, and actually properly classify it and code it, because otherwise that data is worth nothing because we can't use it. So here's another model to show, like here, we have our building systems across the terminal, and we can then find air conditioning units. But if the process through design and construction isn't done right, we can't find those things because people haven't called them what they are. So this is where it's really important if a client asks for a specific naming convention to be used. The reason is because they want to be able to find these particular assets. So, we're now in the process of improving all of our data so that we can actually view it in the different ways we want. So we can see our fire system against our structural. So if we ever need, we had a situation where there was a pipe leak last year, and then we could check in the model where that pipe was, because no one could see it because it was hidden behind ceilings. But in order to do that, the data needs to be structured. And then the final point that I would like to make today is in terms of this whole process of bringing the industry along so that we can utilize models throughout their full life cycle, is we have to get the contracts right, and we have to form the contracts up right. And we're in a process of having a discussion in collaboration with Copenhagen Airport around how do we structure contracts so that we get what we want and encourage collaboration. And out of that, I've recently developed this what's called a V model, which comes from the system engineering world, where we start at the top with our business drivers and our strategy, and then that feeds down the process through project delivery strategy, what collaboration elements we want, and how should they be in the contract. And then it's not until we've made a contract that meets those requirements that do we then jump to understanding the BIM strategy. Once we understand our BIM strategy and our BIM execution plan, okay, then what BIM uses do we use? And then how do we use those to then deliver the project? And once the project's delivered, how do we get that information to the asset management? And if there's a change at one level, we then flow back through the V to understand how all those changes impact down the chain. So if there's a change in the project delivery, we need to speed things up. We go, okay, is there a way that BIM use could help us improve that? And then yes, it does. Okay, how does it impact our BIM strategy overall? And how is that going to then adjust? Does it fit within the confines of the contract? And if we change the contract, how does that affect collaboration? And then back up the chain to will it meet our business outcomes? So this is the first time I've publicly showed this, but I think this here really sums up the thinking that should be put around projects of, starting at the top. Okay, what's our asset management strategy? What does the project want? And then it's working through all the steps to then figure out, okay, how does the technology then impact that delivery, and then how do we feed that information into the asset management lifecycle? So I think I've taken up all my time. Thank you for staying online and paying attention, I hope. And any questions, I can jump in. If anyone's got questions about models or some of the things I presented, feel free to ask.
Thank you, Carl. Really great presentation. Yes, we do have questions from our listeners. Actually, quite popular question, but maybe you could answer it from your point of view, from your experience. What are the benefits of digitalization to client and end user in terms of cost and benefits?
So a big one is for us is having a model of our existing terminal really helps us with future planning. And we see a lot of, can't really put a number on it, but it's significantly helps projects when you've actually got information about your existing facility and then being able to provide that to the designers so that they can actually start coming up with solutions, and you can better see how projects can tie into that facility. That's a big one for us. And the other one is, we haven't got there yet at the airport, but if you think of cleaning in a building, it's often the biggest operational cost over the life cycle. So really understanding, changing the way that a building could be cleaned, for example, like rather than cleaning a space every 2 hours, how about we clean it only once if it's been used a certain amount? Because often we just have people going through just on a cycle, but what if we start reacting to actual usage? So like on an airport, it would be, we might not have to clean a whole pier for a day because no planes have come there, but then if we know a flight's coming, that's when we send cleaners 2 hours before to make sure everything's good, so we have a better user experience, and then that also helps, streamline cost. So that's a couple of examples.
All right, thank you. A few more questions. Could you tell us how one should plan a roadmap for digitalization? For digitalized project management?
I think, you really need to start back at the strategy level and really understand what you want to get out of it. So, for example, at the airport, our aim, we have a strategy to use digitalization to improve to capitalize on the value of digitizing our assets. So, and we also want to have a past, present, and future view of our terminals. So that's really a driver and why we want to get it out of projects. So the first thing is understanding the why, and then working from there. It's too easy to go out and just buy a piece of technology and then start using it and kind of falling into it. So I think you just need to really understand why. Like, what is your business driver? Like, are you an asset owner who's trying to better manage space, or are you a construction company who's trying to improve delivery times so that you can generate more profit? Are you an architecture firm that wants to spend more time on design rather than producing the documentation manually? So it's like, looking at your business, where do you want to be, and then building the systems around that.
Okay, thank you. So the last one question, real quick. Have you managed to link the models with BMS system, and if yes, to what extent? And also, have you integrated the models into a specific FM system? So
at the moment, we haven't at the airport. That we have a BMS system that could take the models, but the thing is, the whole terminal isn't of an equal. The whole terminal model isn't of an equal standard that you could put it in. So there would only be some assets that would have a model component in the system. So then it makes no sense to do it yet, because you would have half the building managed the old way and half the building managed the new way. So for us, it's more, it wouldn't happen until we had one whole like asset type mapped across the terminal that could then be fed into that system. And in terms of FM systems, we were in the process of getting something that would accommodate the models, but because of COVID, we had to stop that process.
All right. So if that's all, yeah, I see there are a few more questions, but unfortunately we are running out of time, so we must welcome already the next speakers. Carl, again, thank you for a great presentation and great Q&A session. You can stop your screen sharing. And thank you. And I would like to invite our next speakers, Simo Hakkarainen and Juuso Salonen from Peikko Group Corporation, Finland. Welcome. You can start your screen sharing.
Hello, Dana. Hello, all. Just trying to get the screen shared from the right point. Can you see the screen now?
Yes, we can see that. Thank you.
All right. Hey, greetings all from Finland, and thanks for Construction Digitalization, Dana, for inviting to come on this event to present faster, safer, and more efficient way to design building frames. My name is Simo Hakkarainen, and I will be starting the hosting, and together with me here is Juuso Salonen from Peikko. Shortly about the session time frame, I will start with explaining and describing some typical challenges in building frames, what we have found out in Peikko. And in the second part, I will introduce a fast, safe, and efficient frame with delta beam, in a way pointing out how much the frame and the floor structure has an impact on the building. And in the third part, in the last part, Juuso will be telling you about our experiences and our customer processes for effective frame design with BIM and model sharing environment, which is coming all the time more and more popular. And in the end, we have time for the question hosted by Dana. Shortly about Peikko, we are a global company. Our aim is to change building industry to be more efficient. Our three main businesses are slim floors, presented mainly today, but we are also delivering goods for connection technology, also in the building frames, precast and cast-in-place connections. In addition, we have a third business, which is wind energy applications. We are producing foundation solutions for those, and the existence is more or less at least all the continents. Our aim is, of course, understand our customer needs. I think in the audience there is representatives from all of these categories: construction companies, investors, designers, precasters, and the aim is for us to consider how this frame, how can we make your life efficient, and that's something I will tell you today. So as I mentioned, building frame has actually quite big and important role in the building in all the stages. It starts from the development, design, and construction phase, where usually the efficiency and the speed is the key. There is a lot of big decisions made on that time, and it's been estimated that up to 30% of the costs and the CO2 emissions, which is also important aspects nowadays, is created during that period. Then, of course, we are creating spaces eventually for the people to stay in, to have their functions. And sorry, I have some other open. And then becomes the operating phase of these spaces, where, as Carl mentioned, the cleaning, heating, cooling, and these kind of aspects are really important. And with the frame solutions, we can have also impact on those efficiency, costs, emissions as well with the frame, with the clever frame solutions. So, part one, typical challenges in construction based on our experiences with our customers. As seen in earlier presentation, it's pretty complex already starting from the development stage and design stage. There is multiple stakeholders, users, developers, then becomes designers, and with all their needs, requirements, and systems airports, hospitals, all type of buildings. There is a lot of things that need to be described in early, for example, this building BIM standards and this kind of things that we have seen in earlier presentation. So this is a really complex world we need to meet in the future. Then when we are creating these spaces, when we consider them to be used up to 100 years, they need to be efficient to run, but of course, in addition, to be adaptable. We have been seeing buildings used change from apartments to offices or vice versa, or for example, airports functionalities will change in a time to come, they will expand, and that's really important, but the frame is something that is not so flexible to change in the later stages. Then we come from the visual aspect. Of course, we want to stay and do all of our actions and functions in the interior, which is open and welcoming, nice and decorated. So this is something that we want to have open spaces. We need to have this kind of visually attractive premises for the buildings. Mentioned already, but just to understand that building construction need to be, of course, safe. It's during the implementation phase, everybody wants to get back home safe, and that's something. But of course, the operational stage that these things are taken into consideration, that it's also safe to maintain and operate and fast to implement, because the investors, users, there is usually quite strict timeline to make the building happen, and the return of investment, for example, is coming when the building is operational, or for example, hospital can be opened earlier, and that's and time agreed. Something about the maintain and the technical requirements. We want to use, or customer want to use non-toxic materials, easy to clean, mentioned already, and the floor is actually having a quite big impact, the frame also, where the columns are located, which kind of floor material, not only meaning the surface, but the full as a such, having an impact on these requirements and making things challenges for the designers and all the parties. This is my favorite picture, because I think it's actually from one airport. I see that Carl has been also stationed in Finland, so it's a Helsinki airport, and there we can already see the amount of ducts, amount of electrical wires, amount of steel structures in the premises. It's huge, and the collisions are inevitable, and that's why we need to optimize some things, which I will show you later on in my presentation, to make this world easier. So the second part, how can we meet these challenges or the questions mentioned earlier with delta beam slim floor structure to make it faster, more efficient to design building frames? Shortly, what is delta beam slim floor structure about? I don't go so deep into the details, because we are now more also concentrating on the beam, but shortly, it's a beam that that can be integrated inside the slab systems, invented here in Veikko quite many years back, and used already 15,000 projects globally. And it's used composite action. It's a steel box beam filled with concrete on side, and in addition it has an integrated fireproofing, and it enables, as you can see on the right box, more slimmer floors in the buildings and making the ceiling smooth compared to many other options. One solution, several advantages. So as you saw already in the earlier slide, additional room height can be achieved based on using composite action between concrete steel. We can make longer span, meaning less need for columns, and architectural freedom is coming because we can produce beams in quite complex shapes as well on our factories. Lower heating and cooling if you can optimize the space, the amount of cubic meters, space-saving installation, and fast and safe to erect. I have a few slides presenting more detail on these advantages later on. One of those advantages, because the construction methods varies from place to place, and in some cases some other slab system, column system is optimal. With the delta beam you can use hollow slabs, steel decks, filigrane type of slabs, or even wood timber slabs. And also same goes with the columns, and later on you can see or user will introduce that they are all suitable with BIM design, so these standard details are important for all these. So it's not only about beam, it's also about beam connections. None frame in history hasn't been pulled up with the connection details. They really count. In addition, Veikko is offering, just a short slide, we can offer also composite columns, meaning there is a steel tube filled with concrete on site, so it can be really optimized, connected with delta beam with the similar structure. They are light to install, they are fast, it's prefabricated as well, and it offers steel flexibility, but concrete durability, utilizing also the composite action. We can easily make, for example, 3-story high columns and erect it and once, so it's really effective on site, fast to do. And 3D BIM design process also available, and local service on the countries presented earlier. In addition, hospitals, airports, offices, the HVAC doesn't go only in horizontal, it also go vertical direction. Veikko has in its offering Petra slab hanger, so with this you can make easily openings for installations, and it's the easiest way to make a fireproof openings. It doesn't either require any surface treatment, fire paint or such. And standard safe solution, all these measurement tables are available, so you don't need to custom design it for your projects. Short note, what is emerging in many markets is the emerge of hybrid slabs, meaning utilizing timber, concrete, steel together, and delta beam is really suitable for that option as well. We've been seeing nice examples that delta beam is used, and it's also creating this visual nice layouts when you can leave the timber visible in the building. Here is also a story for more material about the sustainability. I don't go so deep in my presentation now, but you are able to find more information. How can you optimize? How can you make more sustainable solutions with delta beam as well, meaning less cubic meters. And we have also introduced a beam made out of recycled steel, so you can even further cut your CO2 emissions. But maybe that's the topic for the... So, short summary. We can offer with delta beam space for people instead of structures, having more slender for more slimmer option, and then now it went one slide, but more longer spans. Technical installations are easy, as you can see in the picture. The beam is integrated in the system. We can offer fast, reliable, and high quality deliveries. And in addition, there is it's enabling these fast and safe assembly with demanding shapes easily. And in addition, you can use the construction details, connection details of our offering in your projects. Now I will leave the stage, short one slide about custom design and BIM and FEM model sharing, and now Juuso will introduce your practical examples about this topic. So thank you for the first two parts. Juuso, the stage is yours.
Thank you. So, hi everyone, I'm Juuso, working also here at Veikko with Simo. So, I will change this now. So, I'm trying to speak more practically about how our BIM delivery is suitable for this kind of BIM process of building project. So, first of all, one of our biggest aims is to give as much support for the designers as possible to design our products. So we have free pre-selection tools and also free final design tools available for some of our products. For delta beam, it's delta beam select. it's running on cloud, so you can try it out yourself with just your browser to find out the optimal delta BIM profile for your project. Standardized connection details are available for all materials, for in situ concrete, precast steel, composite steel, and also wood is now coming, so that we will have standard details for wood connections, delta BIM and wood connections. We have wide selection of component libraries. We are supporting AutoCAD and Tekla and Revit very widely with almost all of our products, and then also a smaller support for other softwares is available. The final dimensioning is always done by Peikko. So when the final design is being done, we get the initial information, and that we will then do the final design and send it back to customer. So more about that later. So here's for example, for healthcare buildings, the characteristics that are kind of typical for these big projects. So this same goes for all big projects, but maybe it's easier if we think of it one type of building. This. So there is big amount of structural elements and also big amount of beams. The profiles are big because we have long spans and typically quite big loads also. And we have a huge amount of participants, all the design sectors, end users. If it's a public building, typically some representative also from the public sector. So information needs to flow fluently. And here the BIM collaboration comes essential, you could say. So this is showing the workflow of delta BIM design in a project. So first we have some kind of initial project planning phase where the project architect and typically some structural engineer is making the big lines of the building, what kind of frame system there should be and what are the space needed in the project. After that, there is a pre-offer stage where this offer stage material is being created, and in that point also, okay, we lost some lights here, but thankfully, thankfully there is still some light left. Oh yeah, it's 5 o'clock in Finland, so our office shut down.
Saving the electricity.
Yeah. So here in the pre-offer stage, the designer is choosing what the delta BIM profile is, so that we have the space requirements set already. So we know the outer size of the beam, so that we know that what space is left for slabs and HVAC and all other material put into the building. And here our delta BIM select can be used, so customer can or the designer can check with the delta BIM select tool what profile is suitable for the project. Also for more complicated design, or if help is needed to select this optimized beam layout, we can also offer that, so our engineers can also do the pre-selection for the project. Then the third stage here is after the offer stage. The structural engineer does the final design, and here all the typical design softwares are used, and we are at least trying to give the tools to make the design with our products. We have also our own free Peikko Designer software, which is shown there on the bottom. So for connection items, the designers can design the correct connection items with Peikko Designer. And then when we start the design, we make the final design of the beams and make the assembly drawings for our own production. And the last stage is that structural engineer checks that everything is as it should be in our design. So about the different data flows, that how information can be exchanged. Here's the first option, which is the traditional one, where two-dimensional drawings are used. So we get the drawings by email and then do our own design and send back two-dimensional drawings of the beams. So everything is handled in plan drawings and dimensional sheets and exchanged with email. And there is quite long iteration time, of course, because information flows between persons. And but of course, it's quite simple in a way. So there is no big technical barriers for the cooperation. You only need some two-dimensional drawing software and email to do this. But it's slow, quite labor-intensive, and there is high risk for human mistakes. And for especially for these bigger projects, it's very heavy work to handle these big projects with this kind of system. So then the second option is based on IFC exchange between participants. It's basically the same as the option one, with the exception that the information is not in plan drawings and dimensional sheets, but it is in the IFC. I'm sure that this format is quite familiar with everyone. So the kind of the benefit from this is that we are working in the same coordination system and inputting data to this in BIM software. So we get some kind of IFC and we can model the beams according to that and send the modeled beams back as IFC. So then the structural engineer and the end user can have the beams in their BIM model as they are actually built. So the big benefits of IFC is of course that there is possible cooperation between different softwares. It's not software related, and it's quite easy and fast to transfer the data. It's not a big hassle. There is from our point of view, it's a bit limited to use the data. We basically use it as a reference point for the coordinate system. Basically, that's it. Maybe we check some details from there if they are modeled. It's at least at the moment limited a bit how much we can add more data there. For example, these erection sequences. Probably this will evolve and more softwares will be available where these are possible to do. It's also quite manual work still, so it's a different way of exchanging the data manually, I would say. So the third option is what we are now doing more and more. Now this is software related. We are talking about Tekla Model Share here, but I think other software producers will follow with similar kind of systems. But we see Tekla Model Share as really good for these big projects. We have all participants working in the same cloud-based model. It's basically real time. We can always assume that the initial data is up to date. Iteration is really fast. If we have some questions or the structural designer notices that there is something wrong or has some comments, it's really fast to iterate the modifications. When we get the model, we enter it, and basically we continue where the structural designer has left the beam. So we don't delete anything, we just add our own information there, and it stays there after we have manufactured the beams. So there is big benefits in that everything is up to date. We can quantify the data, and it's possible to have parallel design processes. So lots of benefits for these efficiencies. Of course, challenges are that it's really heavily software dependent, and also these fittings of our design environments, that everything works correctly when we are using in different companies working in the same model. Also, change management and risk of corrupted data is possible. So we need to have really qualified people to do the modeling. We cannot put someone in this kind of model on the first day at work. So here's an example picture from a model with some connections and delta beams. So it's really easy to visualize these connections. This is helpful in addition to the structural engineer, also our production and sales guys and project managers, that they see that what we are doing in 3D. Yeah, so what's next? Now I lost my notes, sorry. Yeah, here. So what's next? We are planning more integrations. First of all, internally, we are trying to tie our processes more into these BIM models so that we would get up-to-date information of our design status and manufacturing status to be visualized in the model itself. Also, what Simo also mentioned, this CO2 data is something that we are thinking of adding into the model during our model design phase, so that it would then stay in the BIM model. Then also all the design data, so when we make some design calculation, we could also attach that to the actual beam, so that if someone wants to check it later on, it could be found from the BIM object. Then external things, we have already made an API for Delta Beam Select. So the aim is to enable this algorithm-based pre-selection for the profiles. So the designer can have their own algorithm-based design or pre-design running, and that can then send the initial data to our cloud server and get back the correct pre-selected optimized delta beams for their design. And the same kind of things same kind of online services are planned, so that we would have API for between Tekla or other design softwares and cloud to get faster dimensioning and selection of correct products for the design. This could include Delta or Petra or other products we have. Yeah, so this is one example of this hospital projects. So it's in Helsinki, this new bridge hospital that won the Best Public Project BIM Award last year. And as a numbers, the project had somewhat 1,800 delta beams and roughly 1,500 tons of other steel structures delivered by Peikko. So in this slide, it has all the steel structures, so including delta beams and other steel structures we delivered, and also the steel structures that were delivered by someone else. So it was a big project, and this was done in Tekla models here, and I have to say that the design flow was excellent. It went really fluently considering the size of the project. There was basically no problems. So this is like future implications. We are also thinking of this algorithm-based design and how to enable faster design workflows and get faster feedback for customers also to get the best optimized solution possible for their project. But it's all at the moment only in the future, but we have big anticipations for this kind of services and softwares. So here is Delta BIM still in numbers. So in 30 years, over 15,000 successful projects and used in over 35 countries, and we have local services in more than 30 countries. So already proven to be really reliable product, and with these new digitalized improvements, I'm sure that we will be able to make the product even better. Okay, that was the last slide.
Thank you, Juuso, and I think now it's time for the questions from participants.
Yes, exactly. Thank you, Simon. Thank you, Juuso. Yeah, we have one question. Are Delta BIM systems suitable in seismic zones?
Yeah, I can take this. We have made research studies, actually just recent years. Yes, it is in certain, because seismicity exists in different scales, and I would say when the requirements are high and the Delta BIM needs to carry a lot of loads, then it's not maybe it could be used as a secondary structure. But when the seismicity is lower and the Delta BIM, the loads from that direction are less, there is actually available a lot of information, a white paper about the topics, how to utilize Delta BIM. And of course then come the connections, they are really hugely important, and there we need, of course, together with the main designer, to consider how to carry the loads from the beams to the other structures and what is the full stability of the system of the building. But we can send more information about this topic as well.
All right, thank you. Yeah, and I wanted to remind to all the listeners that both presentations from Peikko and from Carl also will be available and will be sent out to all the registered attendees. Okay, so since we don't have, oh no, sorry, we have more questions.
Right.
So yeah, is Delta BIM good for long span without composite panel, or its use with post tension?
Yeah, that's really, I think, seldom, not even, or there is, it's like a that the combination is not so common. I think then you lose some of the benefits. The post-tension slabs is the system of making quite slim structures, but Delta BIM is also utilizing pre-campering itself, and usually that's maybe you also as a structural designer more lately you can explain, but it's I don't know the example of being used with that.
Yeah, but for if you are talking about spans, I would say that 9 by 9 meters grid is still in it's very effective span for Delta BIM, and of course longer span also is possible, but well, it will lose it will not be that effective if it's like 11 by 11 grid. It will be a lot less effective, but
I think
it's still possible with moderate loads.
Yeah, and I think you can still do it, but then you maybe lose part of the slim floor. Then the beam is higher than the slab, so we have make 20 meters long Delta beams in the certain cases, but
All right, thank you. And again, thank you for your time. Thank you for joining us today. So you can stop your screen sharing, and I will welcome our next speaker. And the last one, our member of the board of the association, Jānis Kreits. Jāni, the stage is yours, and you can start your screen sharing.
Thank you. Okay, which screen you see?
The one with the emails.
Oh, okay. Yes. Okay, now it's the
Yep, thank you.
Presentation, the right one. Okay. Sorry. Just a second. So, yeah. Hello, everyone. It's a pleasure to see so many of you here, and thank you for participation and support. As many of you already know, our next big event is BIM conference on April 15th. Conference will be in 3 parts. So the first one will be panel discussions. The next one will be presentations from industry professionals where they will share challenges that they have faced with while implementing BIM. And finally, we will finish this day with the presentation of BIM award. So feel free to apply as a speaker, and also you can nominate your project for BIM award. All the information is available on bimconference.lv. So please visit our website. And finally, please follow us on social media and don't miss any news regarding conference and next BIM meetups and other events. So thank you.
Thank you,
That's
Jānis.
it from my part.
Thank you. And thank you everyone for coming today. So wishing you a pleasant day and evening, and see you next time. Bye.
Bye.
Yeah. Raising the Tobagos, we growing like fresh tomatoes. Them boys on fire, too fuego. We pass it round hot potatoes. Everything is nuevo. I'm with my sweetie like Quavo. Need my cheese, need that queso. Need my bread, need that bankroll. Wake up, yes Lord, I'm thankful. Another day on my schedule.